Find the derivative of f of x equals to x cubed. So take note again, this statement can be also written as d over dx, that is a derivative of x cubed. Alright, so take note that in differential calculus we normally use some kind of rules in terms of differentiating. So for example, if we want to differentiate a constant, alright, constant can be any number, let's say 1, 2, 3, -5, alright, a fraction is equivalent to 0. And there's another one, alright, that is a power rule, which means that we have a function x raised to n. If we derive this, normally we put the exponent at the front of the x, that is n x, alright, and then we subtract 1 to the exponent. Here's what we call the power rule, which can apply here in this particular problem. And we have, of course, the sum rule, difference rule, up to reciprocal rule, which I hope later on we can provide some kind of an example. So going back to this problem, alright, so find the function of x equals to x cubed. Alright, again, we want to differentiate this. So using the power rule, n here is, from this formula, is equivalent to 3. Alright, this one. This means that we have to use this 3, alright, x, 3 minus 1. So therefore, we have 3x squared, which means the answer here is letter A. What is the derivative of x squared plus x cubed? So again, this one is a sum rule. Alright, so we can write again the equation here, x squared plus x cubed. To get the derivative of this, let's get the individual derivative of the term. So this means that we have d over dx, x squared, alright, and d over dx, x cubed. So using the power rule, it's simple. So in this particular case, in the first term, n is equivalent to 2, while in here, n is equivalent to 3. So therefore, since power rule says that if we have x raised to n, we have n x n minus 1 as a derivative. So this means that again 2x 2 minus 1 here, which means finally we have 2x. And also here we have 3x 3 minus 1, and therefore we have 3x squared. And then finally we can add, as you can see in here, we can add this 2. This means we have this equation 2x plus 3x squared. Alright, so this is equivalent to letter D. What is the derivative of 3x raised to 10 minus 5x raised to -4? So again, this kind of a problem is what we call the difference rule, wherein to get the derivative of this, we just get the derivative of each function and subtract to each other. So this means that d over dx, again, this statement, the derivative can be written as this. So 3x raised to 10 minus 5x -4. So applying the power formula, again, don't forget, if we have this kind of equation, if we have xn, the derivative, of course, is nxn minus 1, as per the previous problem. So we can derive this individually, each term. That is 3x10 minus d over dx, positive 5, x -4. Using the power formula, we have 3 multiplied by 10, x 10 minus 1 here, and then minus, of course, we have 5 minus -4, x minus 4 minus 1. We further simplify, we have here 3 multiplied by 10 is 30, x 10 minus 1 is 9, minus, at this part we have -20, x -4 minus 1 is -5. So this means that we have 30 x to the 9 minus negative multiplied by negative, we have positive. So 20 over this negative sign here, exponent can be written as positive if we put this exponent on the denominator. That is like this. So this is our final answer. So the answer here is letter A. So find the derivative of x squared minus 2x multiplied by x minus 2. Alright, so again, this one is product rule. We can use this. And since we have two functions, f multiplied by g function. So this means that to get a derivative of d over dx, x squared minus 2x, x minus 2. So most common method is that, of course, first we simplify the equation. So this means that we can multiply x squared minus 2x x minus 2, and then here we have x cubed minus negative 2x multiplied by x is negative 2x squared, and then here also we have negative 2x squared plus 4x. All right, so we have x cubed minus negative 2 minus 2 is 4x squared plus 4x. Alright, so this is our equation, and now we have a simplified equation wherein we can use the power rule. So the same, to get a derivative of this, x cubed minus 4x squared plus 4x. Again, power rule means x, to derive this, x raised to n, we have n, x, n minus 1. So this means that equal sign. So 3x squared minus 4 multiplied by 2 is 8, and 2 here minus 1 is x, plus here we have 4. So the derivative of x is basically 1. So this is our equation. So what is the derivative of 5z squared plus z cubed minus 7z to the 4? So this is basically a combination of sum, difference, and a constant multiplication, and of course the power rule. So we are just combining this to 1, 2, 3, 4, and then 5. So again we have 5. Find the derivative of this equation, 5z squared plus z cubed minus 7z to the 4th. Alright, so again we can apply the power rule in here. So that is 10 for this one, 10 z 2 minus 1 plus 3 z 3 minus 1 minus 7, this one is 4. Alright, so z 4 minus 1. Okay, so unfortunately I already multiplied 5 by 2 here. So 10 z raised to 1 here plus 3 z squared minus, here we have 7 times 4 is 28, z 4 minus 1 is 3. So this is our answer, and it is equivalent to letter A. Differentiate the equation 3z plus 9 over 2 minus z. So again, this one is a quotient rule. So it says that if you have f of g, that is f is the numerator and g is the denominator, first is to take the derivative of the numerator multiplied by the denominator minus the differential of the denominator multiplied by the numerator over g squared, that is the denominator squared. So in this case we have 3z again plus 9 over 2 minus z. So we just follow this one. Take note that as mentioned here, first we multiply the denominator, that is 2 minus z, to the derivative of numerator, that is 3z plus 9, and then minus the numerator, that is 3z plus 9 multiplied by the derivative of the denominator, which is in this case 2 minus z, over the square of the denominator, 2 minus z, and then squared. So now we derive this 2 minus z. Derivative of this is basically, again, if you are taking the derivative of a constant, normally we take this as 0, and this one is basically 3. Alright, derivative of z, this must be z. Right, the derivative of 3z is 3, and then minus 3z plus 9, and then the derivative of this is basically negative 1. Negative 1 over the square of the denominator. Alright, so we just clean this up. We just distribute this value in here. Also, this one here and here. So that is 3 multiplied by 2 is equivalent to 6 minus z, and then 3, of course, 3 multiplied by z. Minus, we have negative 1 here, so 3z minus 9. And then finally, we have 2 minus z squared. So again, another cleanup. So this negative sign to here is positive, also this one, so 6 minus 3z minus positive. Okay, this time I will eliminate all the brackets, so negative multiplied by negative is positive, 3z plus 9, and then here we have 2 minus z squared. So let's put it here, 2 minus z, 2 minus z, so we have 2 multiplied by 2 is 4. Here we have negative 2z, and then negative 2z plus z squared, that is negative multiplied by negative, z is z squared. So 4 minus 4z plus 2z squared. So here in the numerator again, we have 3z plus 3z. Okay, negative 3z plus 3z is 0, and therefore we have 6 plus 9, we have 15. over this one. So we can keep actually this one, or this one is no problem, because in our answer I think this is the denominator, so we can keep this one, 2 minus z squared. So the answer here is letter D. Find the derivative of 4 multiplied by the square root of x over x squared minus 2. So again, this one is a quotient rule, wherein if we have f of x, that is f is the numerator and g is the denominator, we should derive this in the form of first the denominator multiplied by the derivative of the numerator minus the derivative of the denominator multiplied by the numerator, and then finally dividing the complete equation to the denominator squared. So again, in this case, we have 4 multiplied by x as a numerator, and then we have denominator x squared minus 2. So we just follow this. That is, first we multiply the denominator into the derivative of the numerator, that is d over dx, that is derivative 4 multiplied by x, minus the numerator 4 multiplied by x, d over dx multiplied by the derivative of denominator, and then finally here we don't touch it, that is x squared minus 2 squared. So derive here x squared minus 2, take a derivative of this. So basically we have 4 d over dx. To apply the quotient rule, take note this one is similar to 4 1/2 minus 4 square root of x d dx also multiplied by x squared minus 2. So x squared minus 2, and then finally squared. So now we have a form of, in this case, a power rule. So that is, if we have this equation, of course we put down the 1/2 in front and here, and then we minus 1. So that is x squared minus 2, and then here we have 4, okay, multiplied by the 1/2, and then x 1/2 minus 1 minus 4 multiplied by the square root of x, and then here, as you can see, we have to derive this, that is 2x, that is 2 again here in the exponent, 2 minus 1, so that gives us 1 in here. And of course the derivative of constant is 0, and then x squared minus 2, and then squared. So again, simplify, cleaning up, that is, first we can cancel this one, 4 over 2 is 2, and then we have x squared minus 2, 2x. Here we have negative 1/2 minus 4 multiplied by x multiplied by 2x, by the way, so we have 8. So 4 multiplied by 2 is 8, and then here we have, since we're going to add the exponents, so take note here we have x raised to 1/2, and then here we have x, so add this, then therefore we have x 1/2 plus 1 here is 3/2, and then finally we have x squared minus 2 squared. So we distribute this now again here, so we have 2x, that is 2x multiplied by x, and then the exponent 2 minus 1/2 is 3/2, and then here minus 4x raised to 1/2 minus 8x 3/2, and then here we have x squared minus 2 squared. So as you can see, this one and this one, they have the same exponent, so meaning to say I combine this, so positive 2 minus 8 is negative 6x 3/2 minus 4x raised to 1/2 over x squared minus 2 squared. So let's check our answer. I think we have answer as letter D. So differentiate 2x plus 1 over x minus 3. So again, this form is a quotient. Okay, so we follow the quotient rule. So here, as we have done in the previous problem, we just follow this format. That is, first write the equation, of course, 2x plus 1 x minus 3. So in this format, we just first multiply the denominator, that is x minus 3, to the derivative of the numerator, which is 2x plus 1, and then minus here the derivative of the denominator multiplied by the numerator. So again, numerator is 2x plus 1 d over dx, and denominator, of course, is x minus 3 over x minus 3 squared. So let's do the derivative. So x minus 3, 2x, the derivative is what? 2. Okay, minus 2x plus 1, and then here the derivative of x minus 3 is 1. Alright, so again here is 0. Okay, derivative of any constant is equivalent to 0. And then x minus 3 on the denominator. So therefore, we can simplify this. That is 2x, okay, minus 3 multiplied by 2 minus 6. And then here, we have 2x plus 1 and then x minus 3 squared. Alright, and then we simplify. So 2x minus 2x, this will cancel out. And here we have negative 6 plus, sorry, this must be minus, since we have negative multiplied by positive 1, so we have negative 1 here. So minus 6 minus 1 minus 7 over x minus 3, then squared. So the answer here is letter B. So find the derivative of 1 over the square root of x. So this one is a form of reciprocal, okay? So we just follow the reciprocal rule in this problem. So take note that as mentioned here, 1 over f, any value in here is equivalent to, if we take the derivative of this, is basically negative. The derivative of the denominator, f prime, over f squared. So we don't take the derivative on the denominator, we just square it. So in this case, we have 1 over the square root of x. So again, we take the derivative of the numerator, d over dx, square root of x, alright? That is the denominator. And then here we consider, of course, the negative, because we have negative in here. And then we square, as you can see, we square the denominator, so squared. So in this case, we just simplify this. As we know, we have x raised to 1/2, or this is square root, and then take note this will cancel out, so therefore we have x in the denominator. So applying the derivative, so negative 1/2 x, 1/2 minus 1 is negative 1/2, alright, over x. So we just simplify. Negative, here we have 2, denominator, and then x. So if I put this down here, this will be x positive 1/2. So if this part, if I put it in the denominator, the negative sign in the exponent will become positive. So therefore, we have this form. So we simplify. Negative 1 over 2x, the square root of x. Alright, so this is the answer, and it is equivalent to letter A. So find the derivative of 1 over x cubed minus 4. So this falls into this category, reciprocal rule, wherein we have numerator equivalent to 1, and then we have some term or function in the denominator. So again, this is the format we just follow. That is again 1 over x cubed minus 4. So in this pattern, first of all, is we take the derivative of the denominator, taking it negative, so that is d over dx, okay, x cubed minus 4, and then we get the square of the denominator. So in this case, we have x cubed minus 4 squared. Alright, so again, negative sign. Taking the derivative of this function, we have 3x squared, and then again, this will become 0. Okay, so as is in the denominator, x cubed minus 4 squared. So we just simplify. Negative 3x squared over x cubed minus 4 squared. So the answer here is letter A. Find the derivative of 4x squared plus 5 raised to 10. So again, the complete term in here is being raised to 10. So 4x squared plus 5 raised to 10. So this kind of problem can be solved using our chain rule. Okay, chain rule. Although, of course, since we know already the power rule, if we expand this 10 times, that is 4x squared plus 5, 4x squared plus 5, and then we expand this until we finally expand completely. But then of course it's quite tedious. So this chain rule will save us on doing this, okay, the traditional way. Alright, so the chain rule said that we have to first consider the derivative. If we have this, okay, let's say d over dx, alright, so 4x squared plus 5 raised to 10. Basically the rule is that first we take a derivative, okay, derivative of outside leaving inside alone, multiplied by derivative of inside leaving, of course, the outside. So now we apply it here. So first is to take a derivative of outside leaving inside. So this means that since we have this is our outside and this is our inside. Alright, so normally we take this as 10, and then we have this 4x squared plus 5. Alright, we take the derivative of the outside, so 10 minus 1. And then derivative of the inside, so we take a derivative of this, okay, inside the parenthesis, that is 8x, okay, and of course the derivative of constant is 0. So we have this equation now, 8x multiplied by 10 is 80x, multiplied by 4x squared plus 5. So this is our answer, and it is equivalent to, I forgot to put the 9 here, so this is equivalent to letter D. Find the derivative of the square root of 3x cubed plus 10x. So again, we can write this equation into this form, that is changing the radical sign. Here the square root is equivalent also to the term raised to 1/2, and this falls with our chain rule. And as mentioned earlier, our chain rule basically is a derivative of outside leaving inside, so this means is our outside, and multiplying it with a derivative of inside function. So again, our inside function is 3x cubed plus 10, so just follow it. Again, we want to check what is the use of the chain rule. If you found any parenthesis raised to something, okay, that's give us indication or signal that we can use the chain rule. So again, here the derivative of the outside, of course, 1/2, bring it to the front, 3x cubed plus 10x, and then here 1/2 minus 1 is negative 1/2, multiplied by the derivative of the inside. So here we have 3 multiplied by 3x, 3 minus 1 is squared plus 10. Alright, so we have to simplify this. So 1/2 raised to 1/2, I can put it in the denominator. Therefore, we have here 3x cubed plus 10x. Okay, and then here 3 multiplied by 3 is 9. 9x cubed plus 10. So the answer here is letter A. What is the derivative of 5x minus 2 raised to 3? Alright, so again, we are asked to get the derivative of this equation, 5x minus 2 raised to 3. So I'm gonna solve this using our, again, chain rule. So based on our previous problem, so first we have to derive the outside, that is, okay, so we put 3 at the front, and then we have 5x minus 2, leaving it inside. So 3 minus 1 is 2, multiplied by the derivative of the inside. In this case, we have 5. So negative 2 derivative is equivalent to 0, of course. So therefore, we have 5x minus 2 squared. So this is the answer, that is letter B. So find the derivative of x plus 3 raised to 4 over x squared plus 5 raised to 1/2. So again, this one is a combination of quotient rule and chain rule. So we have to rewrite this equation again. X plus 3 raised to 4, x squared plus 5 raised to 1/2. So again, we follow the quotient rule first. So first is that we have the denominator squared, so raised to 1/2 squared, and then first is to take the derivative of the numerator. So we have x squared plus 5 raised to 1/2, and then we take the derivative of the numerator. So x plus 3 raised to 4 minus, in this case we keep the numerator the same, so x plus 3 raised to 4, and we get the derivative of the denominator. So in this case we have x squared plus 5 raised to 1/2. So we follow the same rule. So again, here this will cancel out, therefore we have x squared plus 5. So x squared plus 5 again in here raised to 1/2, and the derivative of this is basically, of course, we take the derivative of the outside as per the chain rule. So we have 4 multiplied by x plus 3 raised to 3, and then we get the derivative of the inside, that is multiplied by 1. So minus same x plus 3 raised to 4, the derivative of this outside, 1/2 x squared plus 5. So 1/2 minus 1 is negative 1/2, multiplied by the inside derivative, we have 2x. So we can simplify this further. So that is x squared plus 5 raised to 1/2, and then here multiplied by 4x plus 3 cubed, minus, here we can cancel this out, and we have x here, x plus 3 raised to 4, and then x squared plus 5 raised to negative 1/2. So we think of what term we can cancel out, we can factor out. So we have here x plus 3 cubed, and here I can factor out the negative sign. So first, okay, let's watch first the answers in here. So x squared plus 5. We factor out this one. So x squared plus 5. Now I'll get the factor of the lower part. Okay, negative 1. And also this one, x plus 3. So since we have lowest is cubed, so we can factor this now. So what is the exponent? What should be the exponent of this term in order to have positive 1 in here? So we have to put 1 so that at least negative 1/2 plus 1 is positive 1. So again, multiplied by 4 and then minus. Here we have x, and then since we factor out cube, we have to put x plus 3. So this will be kept as 1. X squared plus 5 raised to 1/2 is equivalent to 1. So simplifying further, we have x squared plus 5. And take note that we can put also this part, since we have negative 1/2 as an exponent of this, we can put it here at the denominator, so that at least the exponent will become positive 1/2. And then what is remaining in the numerator is x plus 3 cubed multiplied by this factor. So again, let's simplify this. We have 4x squared plus 20 minus this part, x squared minus 3x, and then we further simplify x plus 3 cubed, and then here 4x squared minus x squared is 3x squared, and then we have minus 3x plus 20. And in the numerator, since we have the same term inside, we can say that 1 plus 1/2 is 3 over 2. So x squared plus 5 raised to 3 over 2. And this is our answer, which is letter D.